So these are two other important exponent rules, but they are the commonly misused ones. So these are ones kids often get wrong, and we want to make sure we get them in your brain correctly. So when we do calculus, you can concentrate on the new calculus rules that we're learning instead of the old exponent rules. Okay, the first one is about rewriting things that are in a radical form. So when you have something like x to the a and then it's to the bth root, and I think a lot of you feel comfortable with a rewrite of the square root of x as x to the 1/2. Okay, and I just want to make sure that you understand where things are coming from in this situation, right? This is x to the first power, and that's where this 1 is coming from. And the square root undoes the second power, and it's so common that we don't say it's the second root, but it technically is, right? So we have kind of agreed that we can leave that off, much like we leave off base 10 when we write log, but that's where this 2 is coming from. And so to kind of generalize this, right, something that is y equals the bth root of x to the a is the same thing as y equals x to the a over b. Now it really does matter which one's in the numerator and which one's the x in the denominator, right? This always tells me the power, and this always tells me which root. And if you mix that up, it's going to be problematic for you. So you're going to want to get that in your brain and feel comfortable doing that rewrite for yourself. Okay. The other one is this, which is y equals n over x to the a power, where n is just some number. Okay, and the big idea is if I want to do some sort of rewrite into some number times x to a power, right, I can bring up something that's in the bottom as long as I change the sign of the exponent. And so this is the same thing as n times x to the negative a power. So sometimes I'll say like cross the line, like going from the bottom to the top, change the sign of the exponent. Let's went from a positive a to a negative a. Same thing, if it was in the top, you could cross the line and move it to the bottom and change the sign of the exponent. Okay, so you need to feel real comfortable doing a rewrite, and I want to go through some examples so that you can kind of see what these look like. Okay, so both of these rules are crucial for us because they help us rewrite expressions into the form some number times x to a power, where a and n are constants, right? So where this and this are constants. So for example, here this is a pretty straightforward one, right? Y equals the 5th root of x cubed. So you should feel comfortable saying, okay, this is the same thing as y equals x to the, and here's where we need to decide, is it 3/5 or 5/3? Because those are two very different numbers. Remember, the power goes on top, the root goes on the bottom. Okay, so x to the 3/5. Over here, okay, again, pretty straightforward. This is that second one, right? Now, when I say cross the line, change the sign, make sure that you're thinking cross the line, change the sign of the exponent. The sign of this constant does not change. It also does not drop to the bottom. The only thing that's moving is whatever has that exponent that's going to come up. And so this is going to be negative 12 x to the negative 3. Okay, so those two things are equivalent. All right, this one, y equals 4 over the square root of x. This is kind of a two-stepper, so I'm going to show you the in-between step, and you certainly can do this. Some of you can do it in your head, and some of you can't yet, and my saying is if you need to write more to get it right, I certainly want you writing more. Okay, so this is the same thing as 4 over, and then I'm going to rewrite this. This is to the first power. This undoes, the square root undoes squaring something, and so this is the same thing as x to the 1/2. I don't want this in the bottom though, right? This needs to come up to the top. If it's going to cross the line, it's going to change the sign of the exponent. And so this is the same thing as 4x to the negative 1. All right, similarly, here we go. I would say the middle step would be to rewrite the bottom. That whole thing squared and then that whole thing cube rooted is the same thing as the quantity x plus 1 to the 2/3. Again, 2 is the power, 3 is the root. And then I'd go ahead and say, well, if I don't want this on the bottom and I want to move it up to the top, then I'm going to have to change the sign of the exponent. And so this is the same thing as 5 times the quantity x plus 1 to the negative 2/3. Okay, here is one that I'm going to see people make a mistake a lot, right? And I want to make sure that you get this right. So I want you to take a second, think of what you think it is. Or pause the video, see what you think it is. Okay, here is a common answer that I get. Common answer I get is this is the same thing as y equals 35x to the negative 6. Okay, and I'm going to go ahead and tell you that answer is not correct. And so I want to make sure that you understand why. Okay, so my goal is to get something that looks like y equals some number times x to some power, right? So the first thing to realize is when I look at this, really the only thing that needs to move is this, right? Because my x can't be in the bottom. I want to be multiplying by it, not dividing by it. And so what I need to think about is I can think about it as 7x to the negative 6 over 5. Okay, but if I want to have this very particular form, then I can also think about this as 7/5 x to the negative 6. And if you're confused about why that is, let's go ahead and just think about it over to the side here. 7/5 times x to the negative 6. Well, if I want, I can always give a denominator of 1, and when you multiply fractions, you go straight across. So that would be the same thing as that. And so those are equivalent forms, but this form that I circled meets the criteria of some number times x to some power, okay, in a way that this version does not. Okay, and so make sure only you are moving the stuff with the exponents from the top and the bottom, or the bottom and the top, and changing its sign. You aren't also moving numbers. Okay, if you want to move the 5 up, that's fine, but then you have to change its exponent from a 1 to a negative 1, and I think that's pretty unhelpful. Okay, also a quick note, so negative exponents make some calculus rules a lot easier. Okay, so negative exponents, they are good for calculus stuff, and you'll learn that calculus stuff in a bit here. What they are not good for is evaluating. Okay, and so positive exponents are really what you want for evaluation. So if I ask you to evaluate this function at x equals 2, let's say, okay, well, it's certainly me plugging 2 into this version right here, not super helpful. Everybody is pretty bad at evaluating with negative exponents, including myself. And so if I wanted to actually evaluate, I would do 7 over 5 times 2 to the 6. This is something I can normally evaluate. Okay, so just a quick note, right? There's some positives and negatives to different kinds of exponents, and that's why we're saying you need to be flexible about which version you use. Okay, so those are some important examples so that you can be flexible in the way you write things to make your calculus life easier.